they just want to be beers. They just want beers. Lizard wants beer. Yeah.
Nice.
They tell them after everything. 14 beer apparently.
Yeah.
And then they have to bust the back for it.
I love that joke. That's a good one. All right. So we don't have too much more to go with factory, but we need to start to, there's an adjacent pattern called abstract factory that we're going to look at. It's usually done in tandem with factory, and that will be the last part of this that we are going to cover. I don't think this is quite going to take the entire rest of the class period, but I'm also known to be wrong about these things. So let's find out, and if we have a little bit of time left over at the end, we'll figure out what to do with it. So last time we finished up talking about the factory pattern, and we actually ended up with a solution. I guess we talked about, where was it? Here we go. We have there was no easy, nice image of it. But I will actually go to Refactoring Guru, and we can take a look at what the final solution UML looks like. We talked about the dependency inversion principle at the end of the class. We were talking about depending on abstractions rather than concrete classes, and wherever we can, creating hierarchies. And then we found that we had a parallel inheritance hierarchy, so we just composed one of the other, and then we ended up with a nice solution where we had a full pizza factory that allowed us to create different styles of pizza, each with different kinds of pizzas, and that allowed us to be very hungry. So we're going to dive in right at the end of this, applying the principle, and we're going to talk about how to incorporate something that should probably be incorporated into this whole project. So far, we've done a good job. We encapsulated the entire pizza creation process. So now we can't have the end user hack into the pizza creation process and get in the way of it. It's encapsulated. The only way you can create a pizza is by calling the methods that are inside of the pizza factories. There's one thing we haven't really talked about, and that's that not everybody wants every ingredient on every pizza. We want the ability to substitute ingredients or to customize the ingredients, maybe even make a new kind of pizza that is an offshoot of an existing kind of pizza. So we want to be able to make sure that this is the case. So each pizza that we used is constructed from the same array list of ingredients. So the user has no control over what's in that array list. You order a clam pizza, it's gonna come with clams. There's nothing you can do about that. It's part of the array list that's instantiated when you order a clam pizza. So one thing to note though is that all pizzas contain dough. All pizzas, except for vegan pizzas, contain cheese. All pizzas, except for those who really hate veggies, it's gonna come with veggies and it's gonna come with meats. So we could, if there was some kind of, you're thinking like decorate the pizza?
Yeah, decorate the pizzas, yeah, because I mean, every pizza's supposed to be the same, except for the differences.
We could do that, but then we would have to specify an entire structure for how to decorate a pizza with the associated ingredients, but yes, we could, we absolutely could. Instead, we're going to talk about how to incorporate this into another level of the factory pattern. So one other thing to note is that these doughs and cheeses and veggies and meats are going to have different implementations based on whether they're New York style or Chicago style or California style or some style that hasn't been invented yet. We want to be able to extend these to new regions. We need to be able to encapsulate the ingredient factories as well, so that we are able to produce the ingredients. So we're going to create some ingredient factories. Factories inside of factories. A factory for creating the pizza, and now a factory for creating the ingredients within the pizza. So we need a factory to create our ingredients. This factory is going to be responsible for putting together the ingredients that are in each of the ingredient families, the veggies and the cheeses and the meats from the prior slide. We also need to make sure that we adhere to the associated regional differences. So how would we create a pizza ingredient factory? Well, we start with the interface. We don't have any implementation in an interface, so we're going to need to be able to create the dough for the pizza, create the sauce for the pizza, create the cheese for the pizza, create the veggies, create the, and this is assuming there's a single cheese and a single sauce, but maybe if you like multiple cheeses, maybe that cheese should be a cheese array as well. But all of these need to be implemented by every ingredient factory that implements this interface. So what do we need to do with it? Step one, build a factory for each region. We're going to implement the pizza ingredient factory as a New York pizza ingredient factory and a Chicago pizza ingredient factory. Then we need a set of ingredient classes to be used with that factory. Since this is done or can be done abstractly, we can share those among regions and create an abstract superclass for that. Then we need to take all of this work that we've done and connect it into our old pizza store code so that each pizza can be customized with different ingredient families and substitute ingredients so that our pizzas are more customized. Questions on what we're going to be doing? So here's what some code for the New York ingredient factory might look like. This is a class that's going to implement our old interface, the pizza ingredient factory interface. So now the dough that is used in a New York pizza is a thin crust dough. So we can say that create dough will now return an object for a thin crust dough. The sauce is a marinara sauce. The cheese is a Reggiano cheese. The veggies include garlic, onion, mushroom, and red pepper. Pepperoni, sliced pepperoni, clams, fresh clams, since it's close to the coast. Since Chicago is not close to the coast, then that has to be shipped halfway across the country. So you end up with frozen clams instead of fresh clams. So that's just an idea of how we could throw together the pizza ingredient factory. Now we have methods for creating each of these different types of the parts of the pizzas. So now if we go back to our pizza abstract class, remember that we had a bunch of fields for this. We can now prepare, we can bring the preparation for the pizza into the pizza subclass or the superclass here. And now we can have the bake and cut and box and name, etc. for all of this. So the prepare method is now abstract because we're going to be preparing different subclasses of this. Since we now know all of the associated ingredients for a New York pizza and a Chicago pizza. Here's an example of the cheese pizza, the subclass of pizza. So we're going to have an ingredient factory for a cheese pizza. The constructor just sets the associated ingredient factory. And then prepare just takes in the associated ingredient factory, since we would have a New York ingredient factory if this was a New York style cheese pizza. And then we would create the New York style dough. And again, we're using polymorphism here to know which type of ingredient factory we have. We don't know it within the scope of this from the superclasses perspective, but as soon as we are trying to make a cheese pizza, we will look at the ingredient factory and say, if you are a New York style ingredient factory, we will prepare this cheese pizza in the New York style. Same thing for a clam pizza. Get a little bit too far. So a clam pizza has a separate ingredient factory. We have a different ingredient factory potentially for each possible subtype of pizza. Because we don't know if it's a New York style clam pizza or a Chicago style clam pizza. The ingredient factory that's passed in is gonna tell us which one of those associated types it is. And then it's gonna prepare it in the associated way based on that ingredient factory. Does that make sense? Here's our subclass for the pizza store. Since remember, we had different pizza stores depending on the location of the pizza store. So we have a New York pizza store that extends the abstract pizza store. We have the create pizza. We still have the create pizza in here, so we just can check the type of pizza in the create pizza. If it's cheese, then we'll make a cheese pizza and pass in the New York ingredient factory. Because the New York pizza store can only instantiate New York pizza ingredient factories. So we know from which store it was ordered. That store can only make the ingredient factories of that subtype, which means that when we go to make the pizza, a New York pizza store can only make New York pizzas with New York pizza ingredient factories. But we've abstracted the code of putting together the ingredients so that it's not different between each of the different styles. We have abstract code where we can, and we let the subclasses decide which type they are, rather than trying to specify that at the abstract level or at the interface level. Questions on this? So the change we made, we have now an additional encapsulated way of creating families of ingredients for pizzas. This is the abstract factory pattern. It's not so different from the factory pattern, it's just abstract because we're not deciding what kinds of elements go on the pizzas, we're letting the factories decide. If we have a New York factory, then we have the New York style of ingredients, so it's more abstract than the old factory that we used. The factory will tell us what type it is, which allows us to instantiate the associated correct type of pizza. Nowhere in our code, in the ingredients, are we determining what type it is. That's what makes it abstract. It's a separate design pattern. Factory and abstract factory are considered to be separate patterns, but they go in tandem a lot. So the abstract factory gives us an interface for creating a family of products in general, not necessarily the just pizza, but you can use this for anything. If you implement abstract factory, then the implementation from the factory is decoupled from whatever creates the products, which is very useful for extendability purposes. Now we can extend different families of ingredients that's separate from the types of pizza. Before, these families of ingredients were coupled to the pizza types, and now we have families of ingredients that are decoupled from the pizza types. We can mix and match those. We can modify one without modifying the other. That's very useful for extendability. What this allows us to do in terms of a factory is now we have separate factories for different products meant for different contexts. A New York pizza shop cannot make Chicago style pizzas. Even if you try to, now they can't. Because there's a New York ingredient factory that is the only thing that a New York pizza store can make. So we have different regions. This is useful in practice for things like different operating systems. If you want to separate the code that is used to make your application run on Windows versus run on Mac versus run on Linux, now you have the ability to do that in a way that can't be mixed up. If you have multiple user interfaces, you can now swap out those associated user interfaces where the code that's written for one, you have an abstract factory for that particular user interface. And then this allows us to kind of move the factories. We can swap out at runtime the different factories and use a different kind of factory to produce a different kind of product, but each factory only makes one kind of product. So it really emulates the real world. A Toyota factory is not going to suddenly accidentally produce a fully functional Ford car. Each factory only produces the associated make that it's meant to. One thing also that this allows us to do, back from the pizza example, is if we run out of a particular ingredient, we can just on the fly substitute the ingredient. So we run out of marinara, we can just go in and switch that up with plum tomatoes, and it propagates to every pizza that used marinara. We don't need to go in and figure out, oh no, which of the pizzas do we make? How many of those use marinara? I'm going to modify my code in all of these places. You make one associated change to the abstract factory, and now it propagates to every factory, to everything that makes a pizza that uses that product. That product is removed and replaced with a single change. So you've encapsulated that change. Does that make sense? This is such an abstract concept that I struggle to know whether this is hit home even at an intuitive level. I know that you don't have practice with it, but coming up with practice for this is really difficult. And I can kind of go on a tangent here where I personally believe that this course belongs in tandem with the next course in the sequence, which is software engineering, where you're actually actively making software. I would love to have a project that you are currently working on where I could say, the way that you were making your objects, now go make it with a factory. That would be wonderful, but we don't have the time and effort in the class to be able to make a project of that size given our time constraints. So it's not really easy for me to give you something that you can go apply this to. So I'm hoping that as much of this as possible can intuitively stick, such that when you do move on to software engineering, you can refer back to this idea and implement it as necessary. But I recognize that this is not ideal for getting practice with this. And I just think that it's a weakness of the current course design that we have. And I want to be very upfront about that because I know that it's not doing you full justice to not get the practice with it. It's a change that I really want to make to this course. So that said, at this really abstract level, are there any questions? Are there any clarifications that I can make about this process? Because I want it to be as clear as possible and as useful as possible as you go to apply this, not immediately, but at some point in the future. The best I can do for now, I think, is if we have Ethan order another pizza. And now it's going to incorporate the abstract factory. So we're going to go see exactly how Ethan's pizza gets made as we follow even the ingredient factories that are being done. So Ethan comes in and says, I want a New York style cheese pizza. So we need a New York pizza store. So in our client code, we say pizza store, New York pizza store equals New York pizza store. That gives us a New York style pizza store. Great. We can take an order at that New York style pizza store. We just use the object that we instantiated. A pizza store knows how to order pizza. So inside of the New York pizza store, we call the order pizza method. Since Ethan wants a New York style cheese pizza, we pass in the cheese string. Inside of the order pizza method, which has no idea what region we are using, it's just a generic order pizza. It calls create pizza on the same string that was passed in, cheese. So we can make a pizza object. Again, we're using the abstract super type here, pizza. And because that's what create pizza is going to return, it calls it on the string cheese. But note that this is now within the New York pizza store. Since this is within the New York pizza store, when we go to create the pizza, we know that it's supposed to be a New York style cheese pizza. When we call create pizza, we're ending up using our ingredient factory. And since we know that a New York pizza store was instantiated with a New York ingredient factory, that's how we know which pizza type to make. So within the create pizza, not within the order pizza, we make the pizza object as a cheese pizza object, passing in the New York ingredient factory that was part of the New York pizza store that is publicly visible here. Once we're inside of this, we're able to prepare the pizza. So we make the associated dough, sauce, and cheese from our factory. So we create the dough, we create the sauce, and we create the cheese. Since this was done with a New York ingredient factory, we know that the crust is going to be a New York style thin crust. We know the sauce is going to be the New York style marinara sauce. And we know the cheese is going to be the New York style Reggiano cheese. Now that the pizza has been made, we go back to the order pizza scope, and the order pizza scope knows how to bake, cut, and box the pizzas, and that's the same for all pizzas. It doesn't matter what the region of the pizza is. It doesn't matter what the ingredient factory was. All pizzas are baked, cut, and boxed the same way. Unless that cut is overridden, like it was in the Chicago. But since this is not doing that, we're not overriding the base way to cut the pizza. So it cuts it up and boxes it like a New York style pizza. It's then returned to the New York pizza store as a pizza object and then passed back to Ethan, who can then go consume it. Does this sequence of events make sense from each associated scope? A lot of this is abstract, and if you look at the associated classes and methods, they have nothing to do with the region, and that's so that we avoid copying and pasting that code across all regions. We don't need to. We can abstract it to a single abstract type that's able to query what is the associated ingredient factory, what is the associated pizza store. The object knows that because of the type of some of its fields. So the abstract factory pattern just gives us the interface for creating some family of related objects without the need to specify their concrete classes. So the UML looks something like this. Here we have the client. The client interacts directly with the abstract factory, with the abstract product, and that's it. Each of those interfaces know which is the associated types the client ordered. So written against the abstract factory, compared at runtime against the actual factory. So when the runtime knows which subclass it is, We have either concrete factory 1 or concrete factory 2. The client specifies it in terms of the abstract factory, but at runtime, we can query what is the type of the actual factory that we need to use. So then it can create the associated products to the specification of the client. And that way the client requests things from concrete factory 1 or concrete factory 2 looks exactly the same from the client's perspective. Think of it kind of like speaking through Google Translate. Depending on the country that you are in, the way that you place an order is going to be different. But if you had some kind of universal translator that was there for you, at runtime, we could figure out what is the associated target language that your order needs to be in. The way that you communicate with the translator is exactly the same. You place the order in your home language, however you'd like. But the way that the translator determines what the associated output is could be something related to the client at runtime saying, I need this output to be in Thai. So then the translator knows what the associated target output is. It can call the associated already embedded factory for translating English to Thai so that the output is ready to go. But none of that needed to be specified at the abstract level. The way that you request that is exactly the same no matter which concrete factory you want to use. It's the same thing for each of the products. So we have an abstract factory, abstract products, concrete factories, and concrete products. In our example, we have the client wanting to make a pizza. So we go through the abstract product, which is the pizza, the abstract factory, which is the ingredient factory, and then we have the concrete New York pizza ingredient factory, the concrete Chicago pizza ingredient factory. And for each of the pizzas, we have interfaces for each of the different components of the pizza, the dough, the sauce, the cheese, and I guess the clams. And then we have concrete classes under that for the different kinds of dough, the different kinds of sauce, the different kinds of cheese, the different kinds of clams. And we construct the associated pizza through just a single query of the user saying, I want a New York style pizza store and I want to order a cheese pizza. The rest of this does all of the rest of that work. So that from the client's perspective, they just say, I want to order a New York style cheese pizza, done. This gives the rest of the structure for that. You will find in industry that if you can implement something where all of the complexity is underneath the hood and it minimizes the complexity for the client, you will have a job. The company you will work for will have work that it can do. If you try to hard code all of this, it's an absolute nightmare to maintain, to change, and it may be a nightmare from the client's perspective. The client may think there has to be an easier way to interact with this, right? Why do I need to specify so much information? Can't it just figure that out for me? This is one of the ways for it to figure it out for you, is to use a design pattern like an abstract factory. Within the abstract factory, every method looks like a factory. Create dough is a dough factory. Create sauce is a sauce factory. The method in the interface or abstract class for that is abstract, and the subclasses all override how do I create the dough? How do I create the sauce? And you'll see this in general, that the methods of an abstract factory class are in fact factories. So in general, we're defining an interface for creating a set of products. Each method in that interface is responsible for a single concrete product that may have lots of different forms. So we need a factory to determine which form we are going to be creating. So it makes sense that if we want an abstract factory, that it's natural for each element of that abstract factory to itself be a factory. Now, the very last thing that I'd like to specify is there is a lot of confusion that I have seen historically between the factory design pattern and the abstract factory design pattern. So I have one last kind of comparison chart to look at what does the factory look like versus what does the abstract factory look like. So I'm just going to reveal all of this and we'll kind of zoom in and zoom around to take a look at it. The factory itself has kind of one variable, the pizza store. So there's one abstraction for the way that we're going to order the pizza and one abstraction for the actual pizza. So a pizza store makes a pizza, a different pizza store makes a different pizza. So we got that parallel inheritance hierarchy that we then composed. The arrows going down there in the composition. An abstract factory goes one level more abstract than that and says we want to be able to modify families of related products. So each one of these pizzas is made up of ingredients. And so we can do things like change the associated dough or sauce or cheese, etc. And each one of those become their own separate factory that have their own separate interface. So the dough is very similar to, if we zoomed back out, it's very similar to the pizza. So we can implement this whole thing as a factory. We can implement this whole thing as a factory. The dough is a factory, the sauce is a factory, the clams is a factory, and the cheese is a factory. And you can start to see how the design patterns chain together and explode the complexity. There's a lot to consider here at the design level. But once you get the design out of the way, the implementation is actually not too bad, as long as you know what you're doing. How are we doing? There's a lot there. There's a lot there to know, a lot there to learn. And honestly, for this to stick, I feel like you need to go do it. And unfortunately, the only existing project that we have for this is one of these code to the API style projects. They don't really require you to make a factory. It's like follow the API. If you do that, you will have made a factory, which doesn't abstract to the level of problem solving of how does one, given an abstract problem, solve it with a factory. You're going to be reliant on the API to create the factory. So you will get that experience. There is a factory-related lab. That said, we'll come back to this for those of you who take software engineering from me. And at some point in that class, I will say something like implement some number of design patterns into the project that you are making. It will be worthwhile because one of those options is going to be a factory. You could make a factory from that. So this may be worthwhile to come back to at some point in the future, once you're actually working on a project that requires that level of design and implementation. But it might not be until the next course you take. There's a long summer in between that and software engineering for those of you who are taking it in the fall. So I'm sorry, I don't know a better way. In the meantime, for this class, try to understand it at an intuitive level. If you can understand this UML and code this to an API standard, that's good enough for this class. Any questions I can answer between the factory and the abstract factory?
So in the factory, did we have any interface?
We had interfaces for so the pizza store was an abstract class. And was pizza an abstract class? I think pizza was an abstract class as well. So we didn't really have an interface. But if we couldn't implement any of the aspects of a pizza, then pizza could have been an interface. If we couldn't implement any of the methods of a pizza store, the pizza store could have been an interface. It's just that with dough, there's no implementation that we know until we know which region it is. We can't do anything with the dough. We can't prepare the dough until we know which region of dough we are making. Now, if we added a third region, a California region that also used a thin crust dough, then we could, for instance, bring up the default being a thin crust dough into this interface, turning it into a class, and then override it with a thick crust dough. So you'd have a default. But when there's only one or the other, and we don't want there to be a default, then we leave it as an interface. Because remember that you can only extend one abstract class, and you can implement an arbitrary number of interfaces. So wherever you can have an interface, that is useful in Java. If you're in another language, it matters less. Some other languages. If you're in C++, it matters less.
So for the concrete factory on the left, if we want to substitute out any of the ingredients, we essentially have to create a new subclass.
Yeah, you'd have to have some kind of Chicago-style clam pizza without clams. I guess Chicago-style veggie pizza with some other veggie. Or and then you'd have a separate style of that.
So it gets kind of bloated.
Yeah, that could turn into a lot of different subclasses if you wanted to make those as objects. Whereas here, now we can start to switch out the ingredients on the fly as we'd like to.
And then here you had out of stock ingredients.
Yeah,
Yeah, it's an easy substitution.
yeah. So abstract factory certainly adds a lot of runtime power at the expense of, this is a reasonably complicated UML. There's a lot going on here. There are lots of ways that this could go wrong as you're constructing it. But once it's constructed and working, extending it or manipulating it is significantly easier.
We used to work with thousands of ingredients, like for our production.
Yeah,
And what we did is so I'm like trying to think of this in a concrete term, but what we went through and we approved multiple suppliers for every single ingredient so that we could, if we couldn't get it from somebody, we could get it from somebody else.
Yeah.
I think this. That seems.
it certainly would. If a vendor is out of something, you could have a backup that you could swap into, because this could auto create the orders for something. If you're writing software, you could, if you're out of system resources for something, you could have an abstract factory for determining, how do I construct a new something that uses less system resources and has some downside to it, but you pre-programmed as things start to run out of, as you start to run out of resources, what is the first thing you should cut? Other questions? Well, this is the end of factory and abstract factory, so I guess I'll spend a couple minutes talking about what's coming up in the class. We're focusing on the exam for the remainder of this week. We need to get a builder lab happening. We need to get a factory lab now happening. We're starting to fall a little bit behind. So starting next week, we're probably gonna have quite a bit of work to catch up on. I'm thinking that by the end of next week, we wanna have the builder lab done. What's remaining for us to cover, we've done strategy, we've done decorator, we have builder, we have factory, and we have observer as the three left to do. I have more design patterns that I can cover beyond that. So we'll probably spend some of the last couple weeks of class covering some design patterns that you don't get labs on. But that does give us a little bit of ability to stagnate some of the design patterns. It just might be a little while between when you see the design pattern in class and when you're actually assigned the lab. I don't think that's great. But that might be the best that we can do, rather than say, all right, I'm assigning all of the remainder of the labs for the quarter tomorrow. They're all due at the same time. I do want to stagnate them so you have time to practice them, get feedback on them, and turn them in. But that also means that I'd like you to have feedback before you have an exam on that topic. So that's why decorator and builder are not on the exam that's on Friday, because you haven't had a chance to turn those labs in, get feedback on them. What that means is that decorator and builder are going to be on an exam that's in week 9. We covered them way earlier than that in the quarter. So one thing that may be useful in those exam preps for the weeks that were the days before that exam 3, we may want to go back and just have a summary of each of the different design patterns, because it might have been a while since you've seen some of the design patterns that are going to be on the exam at that point. Feel free to request that if that's not just part of the structure of the class, if that would be useful for you, because I recognize that it's really difficult to design a course around all of this material in ways that leads to success in an exam-based structure. So we will work together for that. But I don't want to dive into a new design pattern with 9 minutes to go before we have a focus on an exam and then a weekend before we come back to it next week. So I am okay ending class a little bit early. And if you have any questions about the lab that's due tonight, I'll stick around for that and you can let me know and I can help you through that instead. All right, thanks everyone. I'll see you tomorrow. Please come prepared with as many questions as you can for exam study.
That's, good. Look at the building this weekend.